Hello friends, welcome to my video lecture. Myself, Professor Vaishali Shinde from Kekiwag Arts, Commerce Science and Computer Science College, Kaka Sahib Nagar. It gives me immense pleasure to explain the topic Ionic Equilibria. In previous chapter, we have studied chemical equilibria involving the dissociation of chemical compound in solid, liquid and gaseous. In this chapter, we shall study the concept of ionic equilibria involving the ionization or dissociation of weak electrolytes such as weak acids and weak bases, particularly in aqueous solution. Here first we see strong, moderate and weak electrolytes. On the basis of ability of substances to conduct electricity in aqueous solutions, the substances are classified as electrolyte and non-electrolytes. Those substances which conduct electricity in an aqueous solution due to presence of ions are called electrolytes. For example, acids, bases and salts. Those substances which do not conduct electricity in aqueous solutions due to absence of ions are called as non-electrolytes. For example, glucose, sucrose, glycerol, urea and hydrocarbon. Electrolytes are further classified into strong electrolyte, moderate electrolytes and weak electrolytes. First we see strong electrolytes. The electrolytes when dissolved in water ionize or dissociates almost completely are called strong electrolytes. For example, most soluble salts, strong acids that is H2SO4, HNO3, HCl and HBr, and strong bases like NaOH, KOH, etc. The second type is weak electrolytes. The electrolytes when dissolved in water ionize or dissociates only partially to the extent of 5% are called weak electrolytes. For example, weak acids like acetic acid and H2CO3 and weak bases like ammonia and ammonium hydroxide. Then third type is moderate electrolytes. The electrolytes when dissolved in water ionize or dissociates to about 50% may be called as moderate electrolytes. For example, optimized condition of concentration and temperature, strong electrolyte may behaves like moderate electrolyte. Then next we see the degree of ionization. According to Arrhenius' theory of ionization, the molecules of electrolytes when dissolved in aqueous solution split up into positively and negatively charged particles called as cation and anions. This splitting phenomenon of electrolytes in aqueous solution is called as ionization or dissociation of electrolytes. For example, consider the ionization of following electrolyte in water as that is NaCl solid plus H2O liquids get converted into Na plus aqueous plus Cl minus aqueous. These ions produced by ionization of electrolytes combine back to give undissociated molecules. The ions produced by ionization of electrolytes combine back to give undissociated molecules. There exists equilibrium between ions produced and undissociated molecules called as a ionic equilibria. The fraction of total number of molecules of the electrolyte that split or ionizes into the cations and anions is called degree of ionization or degree of dissociation. The degree of ionization or dissociation is denoted by the Greek letter alpha. Hence, the degree of ionization that is alpha which is equal to number of molecules ionized or dissociated upon total number of molecules. The degree of ionization usually increases with dilution and its value becomes maximum at infinite dilution. Then we see the factors which affect on degree of ionization. The degree of ionization of an electrolyte in solution depends upon the following 5 factors, that is, first, nature of electrolyte, second, nature of solvent, third, concentration of electrolyte, fourth, temperature, and the fifth is presence of common ion. Here we see one by one. First, nature of electrolyte. Weak electrolytes are partially ionized, therefore their degree of ionization is low. Strong electrolytes are almost completely ionized, have high degree of ionization, therefore ionic electrolytes are having more degree of ionization. Second, nature of solvent. Solvents with high dielectric constant and high solvating power like water ionizes the electrolytes to greater extent than the solvents with low dielectric constant like benzene. Third point, concentration of electrolyte. Dissociation or ionization of electrolyte increase with increase in dilution. As we dilute the solutions, the ions formed in the solution move far apart from each other and the attractive as well as repulsive forces between the ions becomes negligible, and finally the dissociation or ionization increases. Then next point, temperature. The ionization is an endothermic process and hence degree of ionization increases with increase in temperature. Next factor, presence of common ions. The presence of common ions tends to reduce the degree of ionization, also known as common ion effect. For example, the ionization of ammonium hydroxide decreases in presence of ammonium chloride. Thank you.